Yo, what's up, guys? Welcome back to linear algebra. We're gonna have a lot of flashcards due today, so let's check it out. Let's jump in. 17 of them. What is the forward phase, the algorithm for solving linear systems by Gauss-Jordan elimination? The forward phase is basically where you're eliminating the you're turning the digits below the leading ones into zeros, converting them to zeros. Introduce those ones, yep. What are the free variables in a linear system? Basically, free variables are variables that are not associated with leading ones, aka variables that aren't leading variables. Good. What is the trivial solution of a homogeneous linear system in the unknowns x1, x2, xn? Basically, all of them are going to be equal to 0. Cool. What is the pivot positions of a matrix? What are they? Pivot positions are the locations of the leading ones when the row is converted into a row echelon form, or when the matrix is converted into a row echelon form. Okay. What 4 properties must a matrix have to be in reduced row echelon form? I don't know why my nose is so itchy. What 4 properties must the matrix have to be in reduced row echelon form? 4 properties to be in reduced row echelon form. Rows that contain all zeros, those are at the grouped at the bottom of the matrix. Rows that don't just contain all zeros, the first digit reading from left to right must be a 1. In consecutive rows, sequential rows, basically that are not all zeros, the leading one of the row on top has to be further to the left for all the rows. And then for columns that contain leading ones, there must be only zeros other than the leading one. Good. If a homogeneous linear system has n unknowns, okay, we're talking about homogeneous linear systems, n unknowns, and the reduced row echelon form of its augmented matrix has r non-zero rows, what can you say about the number of free variables in the system? It's going to be the number of unknowns minus the number of rows, so n minus r equals the free variables, or number of free variables. If a linear system has infinitely many solutions, what is a general solution of that system? A linear system that has infinitely many solutions, the general solution is basically a set of parametric equations in which the solutions can be obtained by plugging in values into the parameters, or numerical values. Yeah. All solutions can be obtained. Yeah, good. What are the leading variables in a linear system? These are variables associated with leading ones. What are the 9 chapters of elementary linear algebra? Linear systems and matrices, that's the chapter we're in. Man, I don't even know what comes next. Maybe determinants, Euclidean vector spaces, general vector spaces, eigenvalues, and eigenvectors. Six would be what? Product boxes, dot products, quadratics, diagonalization and diagonalization and quadratics, inner space products, and then numerical sequences, numerical methods, general linear inner product spaces. Okay, I missed it. Inner product spaces, then diagonalization and quadratic forms, then general linear transformations, then numerical methods. What 3 properties must a matrix have to be in row echelon form? Basically everything that the reduced row echelon form has to be, except for that columns can contain other digits than zeros in the leading one. The backwards phase of the algorithm for solving a linear system is basically where you're introducing zeros above the leading ones. If a matrix is in reduced row echelon form, what must be true of the first non-zero number in a row that does not consist entirely of zeros? It's a leading one. It must be a 1. What are the non-trivial solutions, if any, of a homogeneous linear system in the unknowns? Non-trivial solutions are going to be anything that aren't the trivial solution. Okay, anything where all the unknowns are equal to 0. What is a homogeneous linear system? This is where a linear system in which all the equations have a constant equal to 0. How many solutions does a homogeneous linear system with more unknowns than equations have? Infinitely many solutions. What is the difference between Gaussian elimination, Gauss-Jordan elimination? Gaussian elimination, you're just getting the augmented matrix into row echelon form, a row echelon form, and Gauss-Jordan elimination, you're getting it into reduced row echelon form. What is a pivot column? This is a column that contains a leading one, or pivot positions. What are the 9 chapters of elementary linear algebra? By Anton and Call. Linear systems and matrices, determinants, Euclidean vector spaces, general vector spaces, eigenvalues and eigenvectors, inner product spaces, diagonalization and quadratic forms, general linear transformations, and then numerical methods. Good. All right, so what did we read about yesterday? So we finished a section on matrix terminology and notation. We started a section on addition and subtraction of matrices. So addition and subtraction, basically you're going to have to be able to add and subtract matrices. You're going to have the same size of the matrix. The matrices must be the same size for you to add and subtract them. From there, it's pretty simple. You're just going to basically take synonymous entries and add those individual synonymous entries together, or subtract, depending on if you're adding or subtracting. Basically, A11 is going to add or subtract to A, or whatever, B11. Okay. For matrices to be equal, they must be the exact same size. Remember, size is defined by row by columns, and then on top of that, all the entries, the synonymous entries must be exactly the same, all of them, for a matrix, 2 matrices to be equal. Okay. We learned that a column vector, this is a matrix that has basically one column. A row vector, this is a matrix that has one row. They are also known as row matrices or row vectors. Column matrices, column vectors. We learned about some shorthand for writing matrices. The matrices are always denoted with a capital letter unless it's a row or a column vector. Row and column vectors are denoted with a bolded lowercase letter. When you're talking about the matrix, it's typically a capital letter unless it's those exceptions. And then the entries are going to be denoted with the lowercase version of the uppercase matrix name. So the entries would be lowercase a if the matrix is known as capital A. You denote it by, you can say Aij, in which I denotes the row number, and then the J denotes the column number. And this is how you can figure out which part of the matrix you're talking about, which entry. And so if you said parenthesis, the matrix name, capital A, for example, and then 2, 3 equals, then that would equal the entry of matrix A at row 2, column 3. Okay? I think that's most of it. The shorthand is a little confusing. When you have a 1x1 matrix, for example, this is a different thing actually. When you have a 1x1 matrix, you don't typically include the brackets, so it's hard to tell if it's a a matrix or not, you got to use context clues. And there was like some shorthand way of writing the matrix. It's basically capital A equals lowercase a, maybe in brackets, yeah, brackets, and then the ij. Maybe you plug in, for I and j, you plug in the total number of rows and columns, maybe not. That's just kind of a way to shorthand a matrix as far as I understand. So let's see what I got. All right, very nice. That's all good. That's good. Square matrices, we forgot that. So a square matrix, this is where the number of rows and number of columns are equal. There's some way of denoting it. It's like square matrix of something n, where n is the number of rows and columns. But then there's a object essentially within that square matrix known as the main diagonal, and that's defined as like a11, a22, ... ann. So that's the main diagonal. It goes from the top left-hand corner down to the bottom right-hand corner. Square matrix of order n is how you denote that. Okay. Cool. Compact notation. That's what it's known as. Okay. All right. Good. Scalars. So when we're talking about matrices, a scalar is basically a numerical value, numerical quantity, and typically the entries are scalars, I believe. Maybe they're always, but as far as I understand, they're typically scalars. I don't know of any exceptions. All right, finally, we're all caught up. So now I'm going to continue reading, and I'll be back to recall in a bit. All right, guys, now I know how to multiply matrices. That was pretty simple. I've learned it in the past, but I never knew it was so simple to, it's simple. Basically, to multiply matrices, you must have the same number of columns. Yes. You must have the same number of columns in the first matrix as the number of rows in the second matrix, and the new size of the resulting matrix, the product matrix, is going to be the size of the rows in the first matrix and the columns in the second matrix. That's going to be the new size. And to find out what, say, in the resulting matrix, what number is in row 1, column 1, you're going to take row 1 from the first matrix and multiply it by column 1 of the second matrix and add them together. That's what's in 1, 1. What about 1, 2? You're going to take the row 1 from the first matrix and multiply it by column 2 in the second matrix, and then you're going to add them together. So really not that complex. Defining if the product resulting matrix is valid is defined. Determining if the product of a matrix is defined. Determining whether the product of matrices is defined. Of matrices. So the way you're going to determine if a product of two matrices is defined is you're going to use the sizes. Like I already said, the columns in the first matrix must equal the number of rows in the second matrix. If that's true, the product is defined. If it's not, it's undefined. And similarly for addition and subtraction, if the matrices are not the same size in addition and subtraction, then the sum or difference is undefined. We learned about scalar multiplication, so multiplying scalars to matrices. Basically, we also learned to do scalar multiplication of a matrix, you're just going to multiply every entry by that scalar. And then scalar multiple is a definition we learned. It's basically in relation to another matrix. If you can multiply the resulting matrix by a single scalar, then it's a scalar multiple of the other matrix. All right, yeah, I think that's basically everything. Scalar multiple referring to. Yeah, that's everything for today. So I'll talk to you guys later. See ya.